Okay, so this video is to show how one can make a graph in R and can save that graph into a JPEG. And so for that in R, we need to use what we call a graphics device or graphical device. And in R, basically, it's the thing in the computer that you can draw a graph onto. When I say draw, is not by hand, of course, but through the programming command. It can be on the screen, meaning you see the graphics device, or not on the screen, is as in you don't see it. So for example, here on R, if I would go and run that line of command that I have down there, plot CO2, okay, plot CO2 is not a graphics device itself, but it automatically is going to call the default graphics device from the computer. I happen to be working with a Windows computer, so it's called just Windows, the graphics device, okay? But if you're on a Mac, the graphics device is Quartz, and if you have a Unix or Linux system, it's usually X11. You can install X11 as well, for example, on Mac and etc. So now the graph that you see here is in an extra window. That window is a graphics device or graphical device. And you can see the title here, actually. It says R graphics device 2, okay? And it says it's active. So now, I mentioned you have some that you can't see. So why would you want to draw a graph that you can't see? Well, it's because the graphics device that you see on the screen, this is a graph that you can see, but you can't use it outside of the R environment. With the graphics device that you can see on the screen, you can generate a file, a document, that will contain the image of your graph. And so, for example, you can use a PNG or a JPEG or a SVG, that's scalable vector graphic, depending on what you need. Okay. So here I'm just going to show how to do JPEG, and I'm noting the other ones. There's multiple other ones that one can use. And so that's something that if you want to generate an image in another format than JPEG, you can. You just need to look in R. What are the other potential graphics device you can use? We're going to ask R to load up the toolboxes that allows you to draw graph. So we're going to do library graphics, and we execute that command. If you are on a PC, it's Control and R, right? And in Mac, I believe it's Command and Return. So that tells R, hey, make sure that all of the tools to do different graphical representations are that are in the toolbox or in the package called graphics is loaded and ready to use. There are multiple different toolboxes that exist that can allow you to make graphs. Graphics is part of the already built-in stuff that's in R already. You have other tools that you can add later on. We'll learn that in another video later. So also R has a number of already built-in data sets. So for example, there is the CO2 lowercase, C lowercase o, and 2 data set that's in there. So we're going to be looking at, we're going to using that one to generate our graph. So first that we're going to do, instead of generating an object, out of listing values or reading a document into R to create a new data set, we're just going to use the data set or the object that's already in there. But we still want to read and inspect it. So when I mean read and inspect it means, for example, and it's not limited to that, do head, that's the function that allows you to see the first 6 elements of any object that you have. You can also do class, right, which allows you to know what type of object that you have. And here you see in the answer, it says TS for time series. Then, you might be interested to know how many measurements are in that time series, and you can do length, CO2. That's going to be the number of records that you have, the number of measurements that are in that data set or that time series, to be more precise. You can also do summary CO2. Summary CO2 will give you basically what we call the 5-number summary plus the mean. So that's all the quartiles, minimum first quartile, median third quartile, and maximum, as well as the mean. Make the plot of the CO2. So I had it in front of the screen. Notice here when I selected the script window, then it went kind of in the background here, okay? But I'm going to draw the graph here again, and you can see it's not popping in the front of the screen anymore. So that's what I was explaining in the first video, how I like to resize the windows so we can see things, quite easily without having to toggle from one window to another to make our life more simple. And so I like to just size the windows like this. And if I have more windows opening, then I would resize them as well, so I have everything in one screen. A title is often quite important. So I'm going to add a title for that graph. And so here there is another command line that you can run with the function title. And the function title takes at least one argument, for example, main, which will be the main title that will appear center and on top of the graph, right? And so you do main equal, and then with a quotation mark to tell R this is a string of character, atmospheric CO2 in the 20th century, for example. That's what we want to quote. And then after that, we might be, well, I kind of want to show what is the general trend line here. So I'm not going to go into how to actually properly calculate a trend line. So I just choose, a couple of points sort of arbitrarily to have something that would look like a trend line here. And so here I have another function called segment that takes at least basically 2 bits of information. Where is the point where you start, the location of the point where you want to start your segment, your line, and the location where you want to end that segment or line, okay? And so that location, it needs to be noted with an X and a Y coordinate. So here I have X0 and Y0, and then X1 and Y1, and then we can add other arguments. So for example, what kind of line do we want, the weight of the line, etc. And we can also choose the color, and there is a lot of different options or arguments we can use to change what the output will be. And now I'm going to execute segments. And now notice here, now we have that line that has appeared there that gives us an idea of that trend. Again, that's not a proper trend line, but the proper trend line would look a little bit differently. But if we would do a linear regression to get a trend line, it would look somewhere not too different from that.